Oh, this is the exciting part. From here we could do the energy real fast. Let's write the energy. We'll do it again Tuesday, but let's just write it because it's very exciting. Oh, this will light it up even better. You'll be able to see it. Could you calculate the energy from all this? I bet you could. What is the kinetic energy as a function of time? 1/2 m and that v squared, right? 1/2, what is m? M is the mass. What is v squared? A squared. What is square root of k over m squared? K over m. What is cosine squared? Cosine squared. Right? There's the kinetic energy as a function of time. Anything interesting happening there? Look at that. The maximum of the kinetic energy is 1/2 Ka squared. That's weird. What if we said, what's the spring potential energy? It's 1/2 Kx squared. 1/2 K x squared is a squared sine squared square root of k over mt plus phi naught. That's weird. They both have the same amplitude in front of them. 1/2 Ka squared. They have the same energy. If you were to plot these, you have to know what squared sinusoids look like, but it's not hard to figure out. They stay positive and they still act like a sinusoid. Right. So at time equals 0, we'll assume the phase is 0. Cosine is 1. So this would be what the k would look like. It doesn't go negative. It stays positive. Right? This is k. That's the kinetic energy through one cycle. This is where the position would have gone negative, but it doesn't because we squared it. Or this is where the velocity would have gone negative. Right? And then, I don't want to go too far over, but this is interesting. Oh, I got 2 minutes. Now I want to plot the potential energy. It's a sine. A sine at 0 is 0. We'll ignore the phase. There's no phase. I don't know what you're talking about. And it goes sinusoidal with the same amplitude, 1/2 Ka squared. Right? Starts here and it goes like this if you were to plot it out. Like that. That's hard. They're right on top of each other. I know it's hard to see. Right? But what if you added them together? What would you get? The energy is constant. Right? Using these little expressions from simple harmonic motion, we can see that the energy, the mechanical energy of the thing doesn't change. It's constant. Okay? What if you had to do it mathematically, not graphically? Oh my God. What if you added these two things and pulled out a 1/2 Ka squared? What would you get? Sine squared plus cosine squared. What's sine squared plus cosine squared? 1. Where'd the time dependence go? It's gone. Right? The energy is constant with time, mathematically as well. So this all matches all the stuff you're doing on the exam. All right.